जी बेटा अस्सलाम वालेकुम जी. So today I'm going to solve paper 2 A levels chemistry. This is May June 2017 paper 22. ठीक है जी. So let's start with question number 1. So question number 1 says that the composition of atoms and ions can be determined from knowledge of atomic number, nucleon number and charge. Complete the table. ठीक है जी. तो सिंपल सा क्वेश्चन है, सिंपल आपने टेबल कंप्लीट करना है. ठीक है जी. सो एटॉमिक नंबर, न्यूक्लियॉन नंबर, न्यूक्लियॉन नंबर, नंबर ऑफ इलेक्ट्रॉन्स, नंबर ऑफ प्रोटॉन्स एंड नंबर ऑफ न्यूट्रॉन्स. ठीक है जी. सो लेट्स फिल द टेबल. सो दिस इज द सिंबल, सो दैट्स मीन वी हैव लिथियम. Number of electrons given in nucleon number. What would be the nucleon number? This would be the nucleon number, the large number, the big number, that would be the nucleon number. So nucleon number is 6, and nucleon number is, remember, it is proton plus neutron. All right, number of protons are, the small number is the atomic number. So number of protons are 3. All right, and they have given us the atomic number as well. Atomic number means number of protons. And last we have to find the number of neutrons. So neutrons are nucleon number minus atomic number, nucleon number minus atomic number, so that would be 6 minus 3, that means number of neutrons are 3. So we have 3 neutrons present in the lithium ion. This is lithium ion in which one of the electron, it has a +1 charge, and that's why we have 2 electrons, right? 3 protons and 2 electrons because it has lost 1 electron. Now next row, we have to fill the next row. They have given us the number of protons 26, so that means atomic number is 26, and nucleon number, which is sum of protons and neutrons, that would be 26 plus 32, so that would be 20 plus 30, 50, that would be 58. And finally we have to write the symbol. So to write the symbol, let's look at the periodic table and find out which atom has an atomic number of 26. So this is our periodic table, and if you look at this table, iron has a atomic number of 26. So that means this is iron, Fe. All right, so we have Fe, but as you can see, the number of electrons and number of protons are not equal, right? As you can see, the number of electrons and the number of protons are not equal. Number of electrons are less, so that means iron has lost electrons. How many electrons? 26 protons and 23 electrons, so that means it has lost 3 electrons. The charge would be 3 plus, and its atomic number is 26, number of proton 26, and nucleon number is 58, so that would be 58. So this is the symbol of Fe plus 3. ठीक हो गया जी. नेक्स्ट है, बोरॉन अकर्स नेचुरली एज अ मिक्सचर ऑफ 2 stable isotopes. Boron occur naturally as 2 isotopes, B10 and B11. The relative isotopic masses and percentage abundance are shown. So they have given us the relative isotopic mass of both isotopes. The relative isotopic mass of boron 11 is not given, and their abundance, that B10 is 19.78% and B11 is 80.22%. So first of all, they're saying define the term relative isotopic mass. So these are just different terms: relative atomic mass, relative molecular mass, relative isotopic mass. So relative isotopic mass is, it is the mass of 1 mole of an isotope, because they're talking about isotopes, so that's why it is mass of 1 mole of an isotope, of an element. किसी भी एलिमेंट के किसी एक पर्टिकुलर आइसोटोप की बात हो रही है. So this is the mass of 1 mole of an isotope of an element when compared with 1/12 the mass of 1 mole of carbon 12, the isotope of carbon, which is 12 mass. So the mass of 1 mole of an isotope of an element when compared with किसी भी एलिमेंट के आइसोटोप के मास को when we compare it with 112, the mass of one atom of carbon-12, that is called relative isotopic mass. Means we are relating the mass of an isotope with the mass of carbon-12, and that's why we call it relative isotopic mass. Now the next part is calculate the relative isotopic mass of B11. Now we have to calculate the relative isotopic mass of B11. B11 का isotopic mass calculate करना है. Give your answer to 6 significant figures and show your working. So the formula for the relative atomic mass from the percentage abundance of isotopes is the relative atomic mass of an atom is equals to each isotope would be multiplied by its percentage, right, and divide by 100. So first isotope is B10 and its percentage is given, its relative isotopic mass is 10.0129. So B10 would be, its mass is 10.0129 and its isotopic abundance is 19.78. So this would be multiplied by 19.78. So basically this is the mass of B10. This is mass of B10 and this is its abundance. ठीक है जी. So each isotope would be multiplied by its abundance. Now the second isotope is plus, we do not have its relative isotopic mass, that we have to find out, and its abundance is 80.22. So let's assume that the relative isotopic mass of B11 is X. So that would be 80.22X divided by 100. Alright, so now first of all, we need this relative atomic mass of boron, right? And for that we have to look into the periodic table. So the relative atomic mass of boron is, as you can see here, this is 10.8, right? So we would write AR of boron is 10.8. So this is 10.8 is equals to 10.0129 multiply by 19.78. So this is 198.055, 16 to 198.055162 plus 80.22x, and this 100 will be multiplied by the relative atomic mass. So instead of writing 10.8, let's multiply it with 100. So 10.8 multiplied by 100, that is 1080. So that means we have 1080, and then solving it further, it would be 1080 minus 198.05516 is equals to 80.22x. So that would be minus 198.055162, and that is 881.944, and this would be divided by 80.22. So the final answer is 10.9941, because we have to write it in 6 significant figures. So the answer would be 10.99. These are 4 significant figures, then 5, and finally 6. 10.9941. This would be the relative isotopic mass of B11. Alright, so now we are going to start question number 2, right? And question number 2, it deals with the chemistry of nitrogen. So they're saying nitrogen gas is very unreactive. Nitrogen gas is very unreactive. Explain why nitrogen gas is so unreactive. Alright, so this is a 2 marks question, and we have to explain that why nitrogen gas is highly unreactive. So because it's a 2 marks question, so that means there are 2 reasons for the unreactive nature of nitrogen. So basically the first reason is, we know this thing that nitrogen molecule, it is a diatomic molecule. They're attached to each other through covalent bond, triple covalent bond, right? So between 2 nitrogen atoms, there is triple covalent bond present, which is very difficult to break. So the first reason why nitrogen is highly unreactive due to the presence of strong triple bond. Alright, due to the presence of strong triple bond, and the other reason is that both the nitrogen atoms have similar electronegativity value. Their En value is same. Their ability to attract the shared pair of electron is same. दोनों एक ही पावर से आप कह सकते हैं कि electrons को attract कर रहे हैं. So that means their electronegativity is same. And if the electronegativity is same, that means this nitrogen molecule is non-polar. And if it is non-polar, that means there is no charge on nitrogen molecule, and no oxidizing agent, reducing agent, or acid or base is going to attack on the nitrogen molecule, right? So they are highly unattractive molecules, so they are non-reactive. So the reason why nitrogen molecule is unreactive, first reason, they have strong triple bond which is difficult to break, and their non-polar nature, as the difference of electronegativity is 0. Alright, so these are the two reasons why a nitrogen molecule is highly unreactive: strong triple bond and non-polar nature. Now the next part of the question is, despite the low reactivity of nitrogen, oxides of nitrogen occur in the atmosphere through both natural and man-made processes. Although nitrogen is unreactive, but still we get oxides of nitrogen in air, either by natural means or through man-made processes. Explain why oxides of nitrogen can be produced by internal combustion engine. Now, one of the major source from which nitrogenous oxides enter into the air is internal combustion engines. So they're saying that explain how these internal combustion engines, they releases nitrogenous oxides into the air, and this is a 2 marks question, right? So first of all is that nitrogen is, we already said that nitrogen is highly unreactive, but the major feature of internal combustion engine is that there is a lot of heat produced in this internal combustion engine, and that heat would be utilized in breaking this nitrogen triple bond. So although it is unreactive, but it breaks at high temperature, and once it breaks, it reacts with oxygen molecule. It becomes highly reactive. Once it breaks, it goes into atomic phase, and then it reacts with oxygen. So basically, these nitrogenous oxides, nitrogen molecule breaks in the internal combustion engine due to high temperature, right? The triple bond breaks and nitrogen will react with the oxygen present. So the reaction would be that nitrogen will react with oxygen due to heat to produce nitrogenous oxides. It could be nitrogen dioxide or monoxide. Monoxide can be further oxidized. So that's why I've just written down NOx. TKG, next part of the question is state and explain using a suitable equation. State and explain. Again, it is a 2 marks question. So state and explain using a suitable equation. All right, so we have to write the equation as well. How oxides of nitrogen produced by internal combustion engine can be prevented from reaching the atmosphere, because these nitrogenous oxides, they are highly, they are environmental pollutants, right? They pollute the air. So how can we prevent them from entering into the air? How oxides of nitrogen produced by internal combustion engines can be prevented from reaching the atmosphere? So basically what we do, we just simply reduce nitrogen into nitrogenous oxides into nitrogen in the internal combustion engine in the catalytic converter, right? So reduction of nitrogenous oxides in catalytic converter. So what catalytic converter do? It simply reduces nitrogenous oxides into nitrogen by reacting them with carbon monoxide. The two major air pollutants which are releasing into the air from combustion engines are nitrogenous oxide and carbon monoxide. Nitrogenous oxide, they causes photochemical smoke, they causes acid rain, they facilitate acid rain by acting as a catalyst, they oxidize sulfur dioxide, right, and they causes smoke. Carbon monoxide again is a very toxic gas which reduces the oxygen percentage in the blood if get inhaled. So these two are highly toxic gases, right? So these two gases will react in the catalytic converter in the presence of a catalyst. The catalyst we use is platinum. So nitrogenous oxide, let's suppose nitrogen dioxide will react with carbon monoxide in the presence of platinum, which act as a catalyst. A redox reaction would occur. Nitrogenous oxide will be reduced into nitrogen and carbon monoxide will be oxidized into carbon dioxide. नेक्स्ट थिंग इज बैलेंसिंग चेक करनी है आपने, हमेशा याद रखिएगा इक्वेशन मस्ट बी बैलेंस्ड, इक्वेशन मस्ट बी बैलेंस्ड. So you have to check whether your equation is balanced, formulas are right. These two things you must have to check. Correct formulas, balanced equation. ठीक है जी. So on the reactant side we have 1 nitrogen, on the product side 2 nitrogen. So just put a 2 with nitrogen dioxide. All right, and we have 1 carbon on the reactant side, 1 carbon on the product side. It is balanced. Now let's count the oxygens. So 2 2s are 4 and 4 plus 1 5. 5 oxygens on the reactant side, 2 on the product side. All right, so now let's just say इसको थोड़ा सा ज़रा हम डिटेल में सॉल्व करते हैं. सपोज मैं इस पे यहाँ पे let's say 4 and 5. So obviously I cannot balance like I cannot put 5 oxygens on the product side because it is CO2. Whatever I will write with CO2, it will affect the number of moles of carbon as well. So let's just say if we put an even number, if we make 2 carbon monoxide, so now this becomes 6 oxygen on the reactant side. So to make it 6 oxygens we have to write 3, and this would disbalance the carbon. And if again you're going to balance carbon, this would disbalance the oxygen. So that means we cannot write 2 with the carbon monoxide. तो आपने रिवर्स जाना है, 2 नहीं लग सकता कार्बन मोनोऑक्साइड के साथ. सो अगर 2 नहीं लग सकता तो आप एक नंबर बढ़ा दें. ठीक है जी, जस्ट राइट 3. सो नाउ let's see that what happens. So now we have 3 oxygens, and again the problem is that we get odd number of oxygens on the reactant side, 7 oxygens, and we cannot balance it with 7 oxygens because this is not just oxygen, ये कार्बन ऑक्सीजन एक साथ अटैच्ड हैं, तो ऑड नंबर में बैलेंस नहीं कर सकते. सो दैट मीन्स 3 भी नहीं आ सकता, 3 नहीं आ सकता, एक नंबर और इंक्रीज कर दे. तो ऐसे आपने जस्ट नंबर्स बढ़ाते जाने, बजाय इसके कि जो इनकरेक्ट नंबर आपने लगा दिया उसको उसके थ्रू आप उसको बैलेंस करने की कोशिश करें. आगे जहाँ आपको लग जाए कि अब गलती हो गई है तो एक स्टेप पीछे जाके जो नंबर लगाया था उसको 1 से बढ़ा दें, तो 4 कर दें. ठीक है जी. नाउ दिस इज 8 ऑक्सीजन ऑन द रिएक्टेंट साइड एंड 4 कार्बन्स, एंड दिस कैन बी इजीली बैलेंस्ड बाय पुटिंग अ 4 विद कार्बन डाइऑक्साइड. सो नाउ द इक्वेशन इज बैलेंस्ड. सो आई होप ये थोड़ा सा मेथड आपको समझ में आ गया होगा. ये मतलब दिस मेथड इज़ टू अवॉइड द स्टेक्स. ठीक है, मोस्टली बच्चे एक ही इक्वेशन को बैलेंस करते जाते हैं गलत नंबर्स के साथ, बजाय उसको उसी नंबर से बैलेंस करने के आप एक नंबर इंक्रीज करके देखें, बैलेंस हो जाएगी इक्वेशन. ठीक है जी. नेक्स्ट पार्ट ऑफ द क्वेश्चन इज स्टेट द रोल ऑफ नाइट्रोजन डाइऑक्साइड इन द फॉर्मेशन ऑफ एसिड रेन बाय ऑक्साइड्स ऑफ सल्फर. राइट suitable equations to explain this role. So nitrogen oxides, they directly causes acid rain and they indirectly causes acid rain as well by converting sulfur dioxide into sulfur trioxide, and in this conversion nitrogenous oxides they act as catalyst. ये catalyst का काम करते हैं, और and because they are oxidizing sulfur dioxide, so we can also say that they act as an oxidizing agent, but better is catalyst. So I would write catalyst, right? And the equations, now we have to write the equations, write suitable equations to explain this role. So initially what happens is nitrogen dioxide, this reacts with sulfur dioxide and converts it into sulfur trioxide, and itself it reduced into nitrogen monoxide. ठीक है जी. So let's find out if the equation is balanced. So we have one nitrogen on the reactant side, one on the product side, 2 plus 2, 4 oxygens on reactant side, 3 plus 1, 4 oxygens on product side, sulfur 1, equation is balanced. So this is the first part of the equation where sulfur trioxide was formed. Now the second part of the equation would be in which this, because we have said that we are using nitrogen dioxide as a catalyst, so we have to, the major feature of a catalyst is that at the end of the reaction we get it back. So nitrogen monoxide, it will react with the oxygen in the air and it gets oxidized. Nitrogen monoxide will react with the oxygen present in air to convert again into nitrogen dioxide. All right, and we have one nitrogen on the reactant side, one on the product, 2 plus 1, 3 on the reactant side and 2 on the product side. So this can be easily balanced because with this oxygen, because it is not attached to any other atom, so we can put any number with this oxygen, it get balanced. So I need 2 oxygen on the reactant side. So 1 is already here, so I would write 1 upon 2. And this balances the equation. All right. Next part of the question is suggest an equation to show how nitrogen dioxide can contribute directly to acid rain. All right, this is when nitrogen dioxide contribute directly to acid rain. This was the indirect effect where it was acting as a catalyst. Now because it itself, nitrogen dioxide is an acidic oxide. And acidic oxides, when they get dissolved in water, they lowers the pH of water. So what happens is that if nitrogen dioxide, when it enters in air, now air contains moisture and it contains oxygen as well. So when it enters in air and in the presence of moisture and oxygen, it converts into nitric acid. So this causes acid rain. ठीक है जी. And now we have to balance this equation as well. So one nitrogen on the reactant side, one on the product, and we have 2 hydrogens, so we have to put 2 hydrogen. All right, 2 hydrogens on the product side. Now nitrogens are in balance, so 2 nitrogens on the reactant side, and now we have 6 oxygens on the product side. So 2 2s of 4, 5, and to make it 6 we would write 1 upon 2. So now this is 6 oxygens on the reactant side and 6 on the product side. And if you want to convert it into a whole number, just multiply the whole equation by 2. So this 2 would be cancelled out. This gets 4 nitrogen dioxide, 2, 1 and 4. So you can write either one of them. Okay. Now next part is explain how uncontrolled use of nitrate fertilizers on land can lead to severe reduction in water quality in rivers. Uncontrolled use of nitrate fertilizers. Now basically this is a disadvantage of using excess fertilizers. Fertilizers, they are very important for crop growth, but when we use excess fertilizers, it causes disadvantages, and one of the major disadvantage is eutrophication. They are talking about eutrophication. ठीक है जी. It affects the water quality in rivers. So what happens is these nitrate fertilizers, they contain nitrates, right? And these nitrates are extremely soluble in water. So when we use excess fertilizer, now this is a 3 marks question, right? This is a 3 marks question. So first of all, we have to answer this thing, that how these nitrate fertilizers, they enters into the rivers. So what happens is that the excess fertilizers get washed away into rivers and lakes, ठीक है जी, by due to rain, or during irrigation when they pour water, so that what they also get washed away into rivers or lakes by getting dissolved in that water. All right, so they enters into these excess fertilizers, they enter into the rivers, and once they enter into the rivers, the algae growth multiplies. Because basically when they enter into the river water, let's suppose that if this is river water, so when these nitrates enter into the river water, they get directly they get sunlight, right? They get sunlight and they have water. So all the ingredients for plant growth are present, and algae can grow very easily. So it causes algae bloom. Algae bloom means the whole surface of water would be covered by a green layer. This is called algae bloom. So this whole surface of water would be covered by a green layer. So this is algae bloom. So this causes algae bloom, and due to this algae bloom, it blocks the sunlight, right? It blocks the sunlight, and when sunlight blocks down, the underwater plants, their process of photosynthesis stops. ठीक है जी, and they starts decomposing. So sunlight is blocked, due to which marine plants starts dying. ठीक है जी, their process of photosynthesis stops due to the blockage of sunlight. As algae bloom occurs, the sunlight gets blocked, and the marine life, they would start dying. And these marine plants, they are the major source of oxygen in the river water, right? Due to which fish can survive, because oxygen is oxygen is slightly soluble in water. Mainly the oxygen present in river water is due to the photosynthesis of marine plants. But if these marine plants, they start dying, that means the oxygen content of river water decreases. And another thing which is happening is that this algae, this also get decomposed with the passage of time. This algae also get decomposed with the passage of time. And once this algae decomposes, bacteria starts feeding on it, right? So bacteria feeds on dead algae, and this also decreases the oxygen content of the river water. As bacteria, it consumes the oxygen present in river water. So these two processes, the dying of marine plants and bacterial decomposition, this whole process decreases the oxygen content of river water, and due to which marine life destroys. So drop in oxygen occurs, right? So this whole process is known as eutrophication, and this is how the uncontrolled use of nitrate fertilizers on land can lead to a severe reduction in water quality in rivers. All right, so this is the end of this question. Ji beta. Now the third question, this question is related to physical chemistry. And in this question, they're saying that the first part is from energetics. The hydrogen halides HCl, HBr, and HI can undergo thermal decomposition. All right, in a sealed container, an equilibrium is established according to the equation shown. So this is the equilibrium established. X could be chlorine, bromine, or iodine. Some bond energies are shown in the table. So they have given us the table bond energy values for HBr, hydrogen, and bromine. Use this data to calculate a value for the enthalpy change for thermal decomposition of hydrogen bromide. So we have to calculate the thermal decomposition delta H for the thermal decomposition of hydrogen bromide according to the equation shown. Now they have given us the general equation. Let's write this equation for hydrogen bromide. So this would be 2HBr decomposes to give H2 plus Br2. Right, and because they have given us the bond energies data, and this is only just 1 mark question, so I will just directly solve it, right? The formula for the calculation of delta H from bond energies is delta H is equals to bond energy of reactant minus sum of the bond energies of product. So on the product side, we have hydrogen and bromine. So the bond energies of hydrogen is 436 and bromine is 193. So that would be equal to bond energy of reactant is HBr 366. We have 2 moles of, just remember this thing, this bond energy data is for is in kilojoules per mole. That is, this is for 1 mole of HBr. Now as we have 2 moles of HBr, so this value would be multiplied by, this value would be multiplied by 2. So this would be 2 into 366 minus bond energy of product, which is hydrogen 436 plus 193. So we are just going to solve it directly from the formula. So this is 2 into 366 732 minus 436 plus 193 629. So 732 minus 629, this is equals to 103. So this is the delta H for this reaction. All right, so just remember this thing, whenever you have bond energy data, the formula that you can use to determine the delta H would be delta H is equals to bond energy of reactants minus bond energy of products. All right, now the next part of this question is related to Boltzmann distribution. They're saying that at a temperature of 700 K, a sample of HBr is approximately 10% decomposed. All right, 700 Kelvin पे कितना decompose हो रहा है? 10%. Changing the temperature affects both the rate of decomposition of HBr and the percentage that decomposes, because this is a reversible reaction. You can see that it is a reversible reaction. So that is why they are telling us that changing the temperature affects both the rate of decomposition speed and the percentage that decomposes. Means the extent to which reaction moves forward. This is basically equilibrium condition, right? So the Boltzmann distribution for a sample of HBr at 700 K is shown. So this is the Boltzmann distribution graph for the decomposition of a sample of HBr at 700 Kelvin. EA represents the activation energy for the reaction. This is EA, right? Using the same axis, sketch a second curve to indicate the Boltzmann distribution at a higher temperature. So this kind of graph we have draw them a lot of times in class. So I hope everyone knows how to draw these graphs. So at higher temperature, we know this thing that the rate of reaction increases. That means this graph would shift to the right, right? This graph shows the varying energies of particles, right? This shows the energy distribution of particles which we have in the reaction mixture, right? And this region, this particular region, this region shows the molecules which are basically taking part in the reaction, because this is our activation energy, and we're saying that all those particles which have energy either greater than or equal to activation energy, they can take part in the reaction. But as we increase the temperature, this region would increase, because this region, this height will decrease. As we increase the temperature, the overall kinetic energy would increase and the average energy would shift on the right side. So the new graph at a higher temperature would shift towards right, and peak height will decrease, and we have more particles involved in the reaction. So that means more particles with energy greater than activation energy. So this graph would be something like this. So this would be something like this. So that means the average kinetic energy of the particles are now increased. This is the graph at higher temperature. So now more particles are involved in the reaction. You can see that now these particles are also taking part in the reaction, and these particles, they've come from this side. The energy of these particles have increased, they have shifted on this side, right? And now the reaction rate would be higher. So we have drawn they were saying that sketch a second graph to indicate the Boltzmann distribution at a higher temperature. Whenever you are drawing these kind of graph, just remember this thing, that this graph will start from the origin, and as we are increasing the temperature, it shifts towards right, and more particles involved in the reaction. That means more particles after activation energy. So this is the energy distribution at higher temperature. Now next is they're saying that with reference to the curve, state and explain the effect of increasing the temperature on the rate of decomposition of hydrogen bromide with reference to the curve. Obviously, when we increase the temperature, the rate of reaction increases, and as we can see that, because we have to explain it with reference to the graph, so we can see that at higher temperature, the area above activation energy, the area above activation energy is now increased, right, or it is greater. So we can see at higher temperature, we have to give the reference of graph. At higher temperature, the area above activation energy is greater. That means more particles with energy greater than activation energy, more successful collisions will take place. Right, so when we have more particles with energy greater than activation energy, that means more collisions will take place definitely. All right, so next part is the decomposition of HBr is endothermic. The decomposition of HBr is endothermic. When we if we want to break HBr, we have to provide energy. State the effect of increasing temperature on the percentage of HBr that decomposes. So because it is an endothermic reaction, when we increase the temperature, we're saying that delta H for this reaction is positive. So that means forward reaction is endothermic. So when we increase the temperature, the equilibrium will shift to the right. More product would form. So the effect of temperature on the percentage of HBr, the percentage of HBr increased would increase, right? So we can say that the increase in decomposition of HBr, equilibrium shifts to the right. More hydrogen and bromine would form, right? More hydrogen and bromine would form because as we increase the temperature, the energy of the surroundings would increase. So equilibrium will disturb. So to regain the equilibrium, system will, or the reaction molecules will absorb the additional energy. To absorb additional energy, because forward reaction is endothermic. So when we do endothermic reaction, it will absorb from the surroundings. So the temperature, the energy which we have increased, system will try to lower down the energy level by doing the endothermic reaction, by absorbing the additional energy. So it absorbs additional energy. It absorbs additional energy so that temperature can be decreased and it can regain its equilibrium. So when we increase the temperature of the surroundings, obviously we increase the temperature of surroundings. So when we increase the temperature of surrounding, equilibrium will disturb, and the reaction chamber, it will absorb energy from the surrounding. And when it absorbs energy from the surrounding, endothermic reaction will occur, and in this way it lowers the temperature of the surroundings. All right, now the next part is at 700 K, HBr is approximately 10% decomposed, but hydrogen iodide is approximately 20% decomposed. So they have two samples, one of HBr, the other of HI. They're saying that at 700 Kelvin, HBr decomposes 10% and HI decomposes 20%. Explain this difference with reference to bond strength and the factors that affect them. So with reference to bond strength, that means the HI is decomposing more, so that means its bond strength is less than HI. HBr, the HI bond strength is less than HBr. The HI bond strength is less than HBr, right? And the reason, now we have to discuss the reason. So the major reason is the atomic radius of iodine atom is large or greater. So as the atomic radius increases, the distance between the two bonded nuclei will increase. These two iodine atoms which are bonded to each other, they would have larger distance as compared to bromine, because bromine is smaller as compared to iodine. So when atomic radius increases, the bond length will increase. As the atomic radius of iodine is larger, its bond length will be larger. So if the bond length is larger, that means it would be easier to remove, to break the bond, right? So that's why it decomposes more. Plus, in addition, we can say that HI has more, we can say that HI has more shielding, because it has one extra shell, it has one more shell as compared to bromine. So it would have more shielding, and therefore attraction for shared pair of electron, the attraction, as shielding increases, the attraction for shared pair of electron would decrease. The attraction for shared pair of electron decreases. So that's why it is easier to break hydrogen iodide as compared to hydrogen bromide. Larger atomic radius, larger bond length, more shielding. Three factors, right? Larger atomic radius, larger bond length. These 2 points are related to each other. जैसे जैसे bond radius बढ़ेगा, bond length बढ़ेगी, and more shielding, because number of shells भी ज़्यादा हैं, so that's why more shielding. ठीक है जी. Next part of the question is related to equilibrium calculations. At a temperature above 1500 K, HCl will decompose. Now they're talking about HCl. A sample of 0.3 moles of HCl decomposes in a sealed container. The resulting equilibrium mixture was found to contain 1.5 into 10 power minus 2 moles of chlorine. Calculate the amount in moles of hydrogen and HCl present in the equilibrium mixture. So if we decompose HCl, this would be 2HCl decomposes to give H2 plus Cl2. Now they have given us the starting moles of HCl, which are 0.3 moles of HCl, right? So in start we have 0.300 moles of HCl. These are starting moles, and as they have given only the moles of HCl in the starting, so that means in start hydrogen is 0 mole, chlorine is 0 moles, and the resulting equilibrium mixture, once equilibrium established, it contains 1.5 into 10 power minus 2 moles of chlorine. So at equilibrium, as reaction proceeds further, the chlorine would have, we have 1.5 into 10 power minus 2 moles of chlorine present, right? So if we have 1.5 into 10 power minus 2 moles of chlorine, that means same moles of hydrogen, because they are present in 1:1 ratio. So the moles of hydrogen would also be 1.5 into 10 power minus 2 moles. And now we have to find out, moles of hydrogen are 1.5 into 10 power minus 2, same moles like chlorine. And in case of HCl, you can see that HCl and chlorine, they are in 2:1 ratio. So means whatever the moles of chlorine we have, HCl would decompose 2 times of that, because 2:1 ka ratio hai. So if HCl is decomposing 1.5, if we have 1.5 into 10 power minus 2 moles of chlorine, so the moles of HCl that would be decomposed 1.5 into 10 power minus 2 minus 0.15, इसको डबल करते हैं, So these are the moles of HCl that decomposed, 0.03. But we have to write the moles of HCl present in the equilibrium mixture. So 0.03 HCl decomposed in reaching the equilibrium. 0.03 is decomposed. Initially we had 0.3. So what left is 0.3 minus 0.03. So these are the moles of HCl left. So we have 0.27 moles of HCl present in the equilibrium mixture. ठीक है जी. Next part they're saying calculate the mole fraction of each gas in the equilibrium mixture. Mole fraction calculate करना है. So mole fraction of HCl. Let's say mole fraction of HCl, that is moles of HCl. So moles of HCl that we have in the equilibrium mixture is 0.27 divided by, whenever we are calculating the mole fraction, that means moles of that particular gas divided by total number of moles. So total number of moles would be 0.27 plus 0.015 plus 0.015. So 0.27 plus 0.015 plus 0.015. So that is equals to 0.3. So the mole fraction of HCl would be 0.27 divided by 0.3. So 0.27 divided by 0.3, this is 0.9. So mole fraction of HCl is 0.9. Similarly, we can calculate the mole fraction of hydrogen, and hydrogen and chlorine mole ratio would be same. So 1.5 into 10 power minus 2 divided by 0.3. So 0.015 divided by 0.3, that is equals to 0.05. 0.05. So that means moles of chlorine would also be 0.05. So these are mole fractions we have calculated. All right, so the next part is, in another experiment under different conditions, an equilibrium mixture was produced with mole fractions for each species as shown. So these are mole fractions in another experiment. Write the expression for the equilibrium constant Kp for the decomposition of HCl. So equilibrium constant in terms of pressure, Kp की expression लिखनी है, that would be partial pressure of product. So partial pressure of hydrogen into partial pressure of chlorine divided by partial pressure of HCl, and as we have 2 moles of HCl, so that would be power 2. So this is the equilibrium expression for the decomposition of HCl in terms of Kp. Explain why the total pressure of the system does not need to be known for Kp to be calculated for this experiment. Why we do not need the total pressure? Mostly when gases are involved, we also find out the total pressure, but in this experiment, no need to find the total pressure, right? And we can easily calculate Kp without the total pressure. So why total pressure is not needed? Because you can see that the number of moles of gas, on the reactant side we have 2 moles, on the product side we have 2 moles. So if the moles are same on the both side, that means pressure will not affect the system or the reaction. So as moles of gas are similar on both sides, so pressure will not affect. Pressure not affects. ठीक हो गया जी. Last part है calculate the value of Kp for this experiment. Value of Kp calculate करनी है. So Kp would be equal to partial pressure of hydrogen and chlorine is 0.06 divided by partial pressure of HCl is 0.88 square. So that would be 0.06 multiply by 0.06, 0.0036 divided by 0.88 square, that is 0.7744, and finally 0.0036 divided by 0.7744, so that is 4.64 into 10 power minus 3. 4.64 into 10 power minus 3. Ji beta. So now the last question from this paper is from organic chemistry. The hydrocarbons A C4H10 and B C4H8 are both unbranched. Alright, they both are unbranched, means they both are straight chain structures. A does not decolorize bromine, and as it does not decolorize bromine, so that means A is an alkane, and B decolorizes bromine and shows geometrical isomerism. So B is an alkene which shows geometrical isomerism. Draw the skeletal formula of A. So I think इससे आसान सवाल नहीं हो सकता. A alkane है, unbranched है, so that means के butane है C4H10. Skeletal formula draw करना है. So this is the skeletal formula of A. Next part of the question is the hydrocarbon A C4H10 has a branched isomer. Right, butane का branched isomer is methyl propane. Suggest why unbranched A has a higher boiling point than its branched isomer. ठीक है, ये चीज़ हम स्टार्ट से ही डिस्कस करते आते हैं कि स्ट्रेट चेन आइसोमर्स के बॉइलिंग पॉइंट हायर होते हैं एज कम्पेयर टू branched isomers. For example, butane का isomer है methyl propane, but this one has a higher boiling point. So why it has a higher boiling point? This we have to explain. 2 marks question है. Main thing is it has because alkane or methyl propane, they both are non-polar. Right, they both are non-polar. That means temporary dipoles, the type of intermolecular force present between these molecules would be temporary dipoles. So because it has higher boiling point, butane, so we can say that A has stronger temporary dipoles than its isomer, right? And why it has stronger temporary dipoles? The reason is if we just draw a few A molecules, let's suppose this is one molecule of A, this is another molecule of A, this is another molecule of A. So these molecules, they have larger surface area as compared to methyl propane. Methyl propane, because in chain there are only 3 carbon atoms, so this would have a smaller surface area. This has a smaller surface area, right? So more surface area, that means more point of contacts. There will be more point of contacts between the molecules of A, and due to more point of contacts, these are point of contacts. So due to more point of contacts, they would develop stronger forces. So we can say that A has a stronger temporary dipole than its isomer due to larger surface area. Straight chain isomers would always have larger surface area. It would have more point of contacts and thus would have higher boiling point. ठीक है जी, तो सिंपल आपको ये ध्यान में रखना है कि जो straight chain isomers होते हैं, they always have higher boiling point due to more point of contacts, larger surface area. Next is give the structural formula of B. B का structural formula देना है. ठीक है जी, तो structural formula of B. B is an alkane. 2 चीज़ें given है यहाँ पे B के बारे में. Sorry, B is an alkene. It decolorizes bromine and it has a geometrical isomerism. It shows geometrical isomerism. So that means B 4 carbon atoms हैं, 1, 2, 3, 4. और अगर हम डबल बॉन्ड सेंटर वाले दोनों कार्बन के दरमियान लगा दे तो अल्कीन भी हो गया. एंड नाउ बोथ द कार्बन एटम्स हैव 2 डिफरेंट ग्रुप्स अटैच्ड. इसके साथ एक हाइड्रोजन आ जाएगा और एक CH3 है. देन दिस हैज हाइड्रोजन एंड CH3. सो दैट मीन्स this would be the structure of B. This is the structure of B because if I draw it like this, carbon-carbon double bond. Now both the carbons have a hydrogen and a CH3. This one would also have H and CH3. तो दोनों कार्बन के साथ 2 डिफरेंट ग्रुप आ गए. So that means ये geometrical isomerism शो करेगा. So the structural formula of B would be CH3 CH double bond CH CH3. और अगर आप डबल बॉन्ड ना भी लगाएं तो भी करेक्ट होगा. Explain why B shows geometrical isomerism. Why B shows geometrical isomerism? Major reason is कि it has carbon-carbon double bond. It has carbon-carbon double bond, due to which restricted rotation occurs. Means within the molecule कोई rotation allowed नहीं है. ठीक है जी, restricted rotation occurs, and both the double bonded carbon atoms और both the sp2 carbon atom, दो इन ये जो दो double bonded carbons हैं, they have an sp2 hybridization. So both the double bonded carbon atoms have two different groups attached. So for alkenes to show geometrical isomerism, दो conditions हैं. Number one, double bond, जो कि तमाम alkenes में होगा. Number two, both the double bonded carbon atoms must be attached to two different groups. Alright, so for example, अगर मेरे पास ये alkene हो जिसमें carbon carbon double bond तो है, but both the carbons are attached to similar groups, so this would not show geometrical isomerism. ठीक है जी. Next question is, draw the mechanism of the reaction of B with bromine. B reacting with bromine include all necessary charges, dipoles, lone pairs and curly arrows. तो ये चार चीज़ें हैं जो आपको लाजमी शो करनी है. Dipoles, charges, dipoles, lone pairs and curly arrows. So first of all, let's draw the structure of B. So B is butene. Alright ji, this is BHH, and bromine is bromine. ब्रोमीन नॉन पोलर है, बट ये जो पाई बॉन्ड्स हैं ये इसको अपनी तरफ इसके इलेक्ट्रॉन्स को रिपेल करेंगे, जिसकी वजह से पाई बॉन्ड विल ट्रांसफ़र इट्स इलेक्ट्रॉन डेंसिटी टू दिस ब्रोमीन, जिसकी वजह से ब्रोमीन की जो इलेक्ट्रॉन डेंसिटी है वो उस ब्रोमीन पे जाएगी जिस जो मॉलिक्यूल से जो पाई इलेक्ट्रॉन से दूर हैं. सो दिस ब्रोमीन वुड गेन अ पार्शियल नेगेटिव चार्ज, दिस गेन अ पार्शियल पॉजिटिव चार्ज, एंड एज the electron density from pi bond shift towards this bromine, ये electron density इस bromine पे shift होगी. So we can say, so we have draw the necessary charges and the curly arrows. So then फिर इसके बाद we get an intermediary structure जिसमें double bond break हो जाएगा. Carbon carbon double bond break, CH3, this hydrogen, and now one of the carbon atoms is the bromine attached to it, and the other carbon would have a partial positive charge. It forms a carbocation. और जो Br है, जब डबल बॉन्ड टूटा तो Br would gain a negative charge, so ये न्यूक्लियोफाइल बन गया. Now this will attack on this carbon, so finally we get CH3H, Br, H, CH3. So this is the mechanism, this is the electrophilic addition mechanism. ठीक है जी. अच्छा, बाद वक़्त आपको मार्किंग स्कीम में एक और किस्म का भी इंटरमीडिएरी प्रोडक्ट मिलेगा. ठीक है, जिसमें बेसिकली होता क्या है कि when this bromine molecule breaks, so this bromine it develops partial connection with this carbon as well as with this carbon as well. तो आपके पास जो स्ट्रक्चर बनेगा, so we can draw it like this as well, कि ये आपके पास दो कार्बन हैं, जो डबल बॉन्डेड कार्बन्स थे. ठीक है जी. these two double bonded carbon atoms, they both would be connected to the bromine, the electrophile which first get attached. They both will be attached to the bromine, right? और ये इसके साथ CH3H. So this type of partial structure can also be, or intermediary structure can also be drawn. Now अब जो आपके पास bromide ion है, negative ion, this will attack on one of these two carbons. Let's suppose इसने इस carbon पे attack किया तो इसका और bromine का bond टूट जाएगा. And finally we again get this same structure. So either you can draw the intermediary like this, or you can draw it like this as well. तो दोनों तरह से draw हो सकता है. ठीक है जी. Alright, so now the next part of this question is, explain the origin of the dipoles on bromine in this mechanism. Right, because bromine, it is a non-polar molecule. सो इसके ऊपर जो डायपोल्स जनरेट हो रहे हैं इसका ओरिजिन जो है वो हमने एक्सप्लेन करना है. सो बेसिकली these dipoles generated due to the pi electron density between these two carbon atoms. So this pi electron density, or we can say that bromine is polarized by the electron density in pi bonds, right? Electrons, bromine is polarized by the electron density of pi bond, which is loosely held, and it induce dipole on bromine molecule. ठीक है जी. All right, next part B, the alcohols C and D are isomers of each other with molecular formula C4H10O. C and D isomers हैं, alcohols हैं, molecular formula given है, both isomers are branched. When C is heated under reflux with acidified potassium dichromate, no color change is observed. That means C is an alcohol. ठीक है, यहाँ से हमें क्या पता लग रहा है कि C and D are isomer, the alcohol C and D both are alcohols, right? And both are branched. But C को अगर आप react कर रहे हैं with acidified potassium dichromate, no color change is observed. That means C is a tertiary alcohol, because tertiary alcohols, they cannot be oxidized. Next, they're saying when D is heated under reflux with acidified potassium dichromate, the color of the mixture changes from orange to green. That means D is being oxidized and E is produced. So we get this compound E, which has now 2 oxygens. E reacts with aqueous sodium carbonate to form carbon dioxide gas. That means E is carboxylic acid, because only acids can react with sodium carbonate. And that shows that, or that means that E was formed from D. E was formed from D when D reacts with this oxidizing agent, and we are getting this carboxylic acid. So that means D is a primary alcohol. D is a primary alcohol because only primary alcohols, they oxidize into carboxylic acid under reflux. So identify C, D, and E. So first of all, we have to draw the structure of C. Now C is an alcohol. What major points we have to keep in mind? That C, it is an alcohol. It has the molecular formula C4H10O. It is branched and it is not oxidized by acidified KMnO4. That means it is a tertiary alcohol. So that makes the structure very simple. We have 4 carbons, 1, 2, 3. And to make it a tertiary alcohol, we put the 4th carbon on the 2nd carbon of chain, and OH would be on the same carbon. So that would be CH3, 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 OH. So this is C4H10O. Now it fulfills all the conditions. It has 4 carbons, 10 hydrogen, 1 oxygen. It is an alcohol. It is a branched alcohol and it will not be oxidized by acidified potassium dichromate. Next is the structure of D. Now D is again a branched structure, same molecular formula, alcohol, and it is oxidized by KMnO4, potassium dichromate into carboxylic acid. So that means OH is on the primary carbon. So that means again we have 3 carbon atoms, but this time OH would be on the terminal carbon. So let's say this would be OH, and carbon with branch would be on the same CH3, 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 CH. So this would be the structure of CH2CH. All right, so this is C4H10O. It is an alcohol. It will be oxidized into into carboxylic acid because it is a primary alcohol. You can see that it is a primary alcohol. OH group is attached to the carbon, which itself is directly attached to only 1 carbon atom. And next, or we can say the last structure, is the structure of the carboxylic acid. So this carbon would get oxidized. So we get CH3, CH3, H, C double bond O, OH. So this would be the structure of carboxylic acid. Alright, next they're saying write the equation for the reaction between E and aqueous sodium carbonate. E means carboxylic acid. So our carboxylic acid, its molecular formula is C4H8O2. Reacts with sodium carbonate, Na2CO3. So this is acid plus metal carbonate. We get salt. Salt would be C4. One of the hydrogen would be replaced. This becomes C4H7O2Na. Right, one of the hydrogen, because in acid reacting with metal carbonates, sodium will displace the ionizable hydrogen. Plus we get carbon dioxide and we get water. And to balance this equation, as we have 2 sodium, so we're going to put 2 here and 2 here. So this would be a balanced equation. ठीक है जी. Next, part C, the isomers F and G. Now we have 2 new isomers, F and G, both forms an orange precipitate when reacted with 2,4-DNPH. That means F and G are carbonyl compounds, either they are aldehydes or ketones. F is unbranched and reacts with alkaline aqueous iodine to produce a yellow precipitate. F is unbranched and it reacts with alkaline aqueous iodine, triiodomethane test. G does not react with alkaline aqueous iodine. It contains a chiral center, G, and produces a silver mirror when warmed with Tollens reagent. That means G is an aldehyde. Right, it reacts with Tollens reagent, so that means it is an aldehyde. Name the yellow precipitate formed by the reaction between F and the alkaline aqueous iodine. So this is triiodomethane test or iodoform test. So the yellow precipitate is CHI3 and the name is triiodomethane. ठीक है जी. Give the structural formula of F and G. Now F is a ketone, a methyl ketone, right? And F is unbranched. Unbranched means we have how many carbon atoms? We have 5 carbon atoms and we have a methyl ketone, right? Only methyl ketones can react with alkaline aqueous iodine. So that means we have this methyl group with the carbonyl group, right? And to make it a straight chain, rest of the carbons would complete the chain. So 3 carbon atoms, CH2, CH2, CH3. Now if we count the carbons, 1, 2, 3, 4, 5. 5 carbons, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens and 1 oxygen. So this is the structure of F. Next is the structure of G. The G is an aldehyde and it contains a chiral center as well. And it does not react with alkaline aqueous iodine. So G is an aldehyde. So first let's draw an aldehyde, C double bond OH. Now we have to complete 5 carbon atoms, 2 and a chiral center. Let's make this a chiral center, CH3H C2H5. So this would be the aldehyde. This carbon is chiral center because it is attached to 4 different groups. So that means the structure would be C2H5 CH3 is in branch, CH3 CHO. This is the structure of aldehyde. Explain the meaning of the term chiral center. Now, what is a chiral center? So a chiral center is basically a tetrahedral carbon. A tetrahedral carbon attached to 4 different groups. Alrighty, so this is simple definition of the chiral carbon. Now the last part is related to IR spectroscopy. H and I are isomers with molecular formula C2H4O2. The IR spectra of isomers H and I are shown. So basically this is the IR spectrum of H and this is the IR spectrum of I. Right now we have to do identify the bonds responsible for the principal peak above 1500 centimeter in each spectrum. So we can see that we have a peak at around 15, 16, 1700 and a peak at around 3000. So the peak at around 1700 is due to carbonyl, C double bond O, right? So this would be either carbonyl or carboxyl, and the peak at around 3000 is due to OH. So that means this is carboxyl, 2500 to 3000. So that means we can say in the spectrum of H we have a peak at 1700 due to C double bond O, and the peak at 3000 due to OH. And similarly in the spectrum of I we have a peak at around 16, 17, around 17 something, we can say 17, 20 or 30, and we have this very sharp peak at around 2900 something, right? So these are the two peaks. So the peak at 1720 would again be due to, we can say that would be due to C double bond O, again similar range, and the peak at 2900 that would be due to CH, right? So that means CO. Okay, so we can say that in spectrum of I we have a peak at 1720 due to C double bond O, and a peak at 2900 due to CH. Right, so the first part is done. Identify the bond responsible for the principal peaks. Now in last they're saying name H and I. So we have the molecular formula C2H4O2, C2H4O2, and the spectrum of H you can see that we have a peak at C double bond O and OH. So that means H is a carboxylic acid with two carbon atoms, so it would be ethanoic acid. And in case of I we have a peak at 1720 and due to CO, and a peak at 2900 due to OH, right? So that means it is an ester because we have two oxygen atoms, right? So this would be methyl 2 कार्बन ईस्टर मिथाइल मीथेनोएट। और अगर आप में से कोई ये सोच रहा है कि जो दूसरा, क्योंकि बेसिकली ईस्टर के केस के अंदर C डबल बॉन्ड O ये ग्रुप होता है, सो हमें ये पीक तो मिल गई है, ठीक है, एट अराउंड 1720, बट दिस पीक इज बेसिकली बिलो 1500. You can see in the table the CO peak is at around 1040 to 1300, and in the question it was clearly they have mentioned clearly that above 1500. We are only talking about the peaks above 1500, right? So these are the two structures, and that is the final question of this paper. All right, if you have any questions you can ask in the comment section. ठीक है बेटा जी, अल्लाह हाफिज़.